How cool is that? I've never seen that before. 我们去3D吗?
In the previous video, we explored how PCBs are manufactured, from raw materials to final testing and packaging. In this video, we'll take you inside the PCB assembly process, where components are placed, soldered, inspected, and turned into fully functional electronic boards.
Oh, there you are. Okay. Didn't realize you were behind me. They have the standard operating procedures posted on the wall. This is pretty common for ISO 9001 companies. If you don't know what it is, it basically walks you through the process of receiving, shipping, producing a product, quality control, fixing a product. It basically, everything is outlined. You have processes, you have workflows. And what's really important is not just having the processes and workflows, but knowing that your workers are able to perform and they know what to follow. That's how you're able to identify a product if it's quality. And if something breaks, how do you fix it? Well, you follow the procedures, you document that. And I think you did see that from the beginning of the video where you see all of the different metrics that they perform and the KPIs that they have established. I guess I did forget to mention in the circuit board assembly area, they identify different areas that are fail components, why it's a bad solder. They explain it. So anyone who has a question, they can walk up and take a look at why these components are bad or fail, or maybe it's cold solder joint, maybe it's a tombstone resistor. There's all kinds of different processes to evaluate and take a look at. And if there is a problem, they have manual people to solve it. And they also have machines like X-ray machine that can also solve that for you too. They have 5 different, let's see, is this the front or the back? We're gonna go down this way. They have 5 different SMT lines here. That's surface mount technology, where they are assembling the components on top of the circuit boards. We're starting at the back. I'm gonna walk to the front so I can kind of give you the tour of what the process looks like for assembling circuit boards. Interesting. So the front of this one is on the other side and then they switch, but we'll go down one of these lines over here. Yes, we did have to put on these hats and we had to put on these jackets, and we had to go through an air machine that would dust control the area. So all of the components are here. It looks like they have individual orders that they have cut tape, and they will take the cut tape and they will load it onto the feeders. So they have prepped this machine right here. They basically put together the kit, and they've identified the components that go with the actual feeder. They do have electronic feeders here as well. So you can take the cut tape and feed it through and it will automatically pull it forward for you. You do have to push a button. That saves a lot of time. Typically these cost about $1,000 a piece. That's really what it goes for. The machines are big, they look expensive, but the expense is actually in the feeders themselves. Sorry for the high-pitched noise in the background. It keeps going on and off. So these individuals look like they're preparing and kitting different assembly units here. Looks like he's going to hold the feeder in place. And if you come around to the side over here, you can see him manually feed one of these machines. So he feeds it through. It pulls it through automatically. It takes that tape, ties it around, drops that down, and he's advancing it and then pulling this through. And then this will automatically advance it through the entire stage of pick and place. Now, one thing that's important is he has the tape on the front of that reel. That is really critical to setting this up. Otherwise, if you get tape, or if you get a reel or a cut reel without that tape, it's hard to put it through the process here. And he's pretty fast and efficient. I've seen many people do this and they take a really long time. But like I said, that piece of tape at the very beginning of that is really critical to advancing it through here. And you have to advance it so that the first pick, it's picking out the components properly without any errors. He puts tape down there. That is so clever. I've never seen that before. Perfect. Okay, so after that's done, he's setting that up for the pick and place machine, which is down there. One of the first machines that you're going to see here is a suction machine. So they have the circuit boards inside this rack, and then this machine will suck the circuit boards out, get them prepared, and onto the conveyor belt for it to be going through the stencil machine. Over here, there's an automatic stencil going through. Below that is a circuit board, pop down, it's gonna roll out. And then it should automatically feed another one in and automatically push that circuit board. I guess he pushed it back through. Maybe there's a 2-side I didn't know about. So this is the lead-free material. The alloy is right here. That's the solder paste. It looks like peanut butter consistency, but it's a gray color. And there's a squeegee that pushes it back and forth through the machine. And they basically push it on the circuit board and it goes through all of the holes through the stencil. And then it will drop down. He's taking a look. I'm not sure what he's doing here. He's manually inspecting it to make sure it looks good. He's stacking it on the trays, probably getting it ready for the next step. Meanwhile, they do have this machine here. This is an AOI machine that inspects the solder paste. So if you zoom in here, you'll see that there's gray color covering all of the copper. 我们去山地吗？
山地的对。
我们去看一看。So we're going to take a look. They have 3D. So he can zoom in and he can take a look at that solder paste in 3D to see how thick and consistent it is. That is just magnificent. This machine is so impressive. From here, the solder paste will come out and maybe they're skipping the step for now. Maybe it's an order. I don't know that. Don't know why, but he's probably going to manually take each one of these components. He's manually going to take each one of these boards and feed it through the line here to the pick and place machine that has already been preset by the guys that we saw down at the beginning. It looks like they're doing resistors, capacitors, and small components on this machine. Typically, they have a big machine and a little machine. So they do the big components over here, little components over there. Typically, it would come out and go onto the conveyor where it would go into an oven. And then the oven, I saw one of the lines had a 10-zone oven. So the temperature will heat up and cool down so that that lead-free material will melt on the circuit board in the exact location that it should. And it always melts to the copper, and so it really bonds it at that point. So we'll stop here. So basically at this point, they have all of the components on the circuit board, and now they are manually inspecting it. They have their traveler, and she's evaluating each one of the components, making sure that it looks good. And I've noticed that they have multiple manual steps that is really taken for granted, that there are actually people sitting there looking at the circuit board, testing it to make sure that it's functioning the way it should. I did skip this step to stop and explain what was happening there, but this is the AOI at the very end, and it's a 3D AOI machine like you saw for the solder paste down there. But it does the same thing, but it looks for the components that were put onto the circuit board after it's gone through the reflow oven. Sometimes when the components go through the reflow oven, what happens is they might settle at an angle or they might lift up a little bit. Depends on how it was heated up and cooled down. And that's why it's important at the very beginning, the SOP, the standard operating procedures, they identify what's passing versus failing. So when they run it through production, they know what's good, what's bad. The components have been assembled with the circuit mount. The assembly line is finished, and now these products are having a problem. So it comes over to the inspection station where they might need a little bit of maintenance or manual physical work to make sure that the components are working. In the perfect world, they would be working correctly, but in the real world, it's not perfect. And so they have to inspect it. When there's a problem, they have to have a real human go through and desolder and resolder, or perhaps just resolder the components to make sure that they're working correctly. So that's what this individual is doing. He's going through and making sure that the components are assembled the way that they should be correctly. I see that they have 2 stations here. And if you were to look here, I'm not sure if you can see from the distance, but they have 4 red arrows. And those 4 red arrows identify where the problems are for that specific circuit board. Makes it easy for the technician to identify what parts need to be fixed. From here, it will go over to the QA area, and the QA will be testing it to make sure that the circuit board is finally ready for the next step. And the next step would be programming of those circuit boards. We have found our way over to the QA area, the QA. And what they do here is they have microscopes that the individuals will be working under. They also have camera microscopes, which makes it easier for them to see what's on the circuit board. And then it looks like they have power supplies, at least at this one station. They have a power supply so that they can give power to the component and make sure that it's working the way that it should be. So as we move forward here, they have a miniature little hand microscope, and she's visually examining the components, making sure that everything looks good. And then all of them have the work orders and travelers that are paired with every single set of circuit boards. They have the very first article inspection going through this machine here. And this machine, the individual is examining all of the components, making sure that they are in the correct place, the correct location, as well as comparing it to the schematic to make sure that the schematic is correct and it matches what's on the schematic. And I was asking, what is this? And this is the first article inspection. That's why there's only one circuit board with these work travelers, so that the individuals can compare and check what they're seeing versus what they should be seeing. So once the components are assembled on the circuit board, there are several paths that they could be going. It could be different processes that they're conformal coating. It could be different processes where they're soldering different cables to it, assembling mechanical components and screws. We're going to go ahead and walk through there. But before we do, let me show you a couple of items here. So before they have been separated, they'll get assembled on one big panel, and then they'll come here and they can be separated, or they're calling this the divider area, so they can divide the circuit boards into individual circuit boards. This is slightly different. It's called a coating area, and I was really curious about what type of coating this is. It's not a UV coating, but when you have different medical devices or devices that require special attention, they'll come through and get a special coating on the circuit board. That might prevent the copper or gold plating from anodizing or oxidizing. And then they will go through this process of heat curing before it gets to the end, and they always have a jig or a traveler. So you see that they have the traveler here that they'll use to carry the boards. Now, as we walk through the process here, the next one is pretty common. It's the DIP or the wave solder, where they're having the molting material. I'm assuming it's a lead material where they have jigs and fixtures that they put the circuit boards on, and then those jigs and fixtures, here's one, it would be going through this machine. And this machine would be hot material heated up to a liquid, so hot metal heated up to a liquid going through, and then it elevates it as it comes out, and then it will come through here. It cools down in this area, and then by the time it gets down here, the workers are able to take the components off the conveyor belt, remove them from the jigs, put them into the travelers, and then take them over to the next area or the next station. Pallets. Now, these guys can do small production, or they can also do really large production. If they do large production, then they'll make SOPs and they'll print those SOPs. But otherwise, for small production, they'll take a sample and try to build the product according to the sample. Here, it looks like there's metal that they're maybe type of heat sink that they're screwing the circuit board and different components to for part of the assembly process on this product, whatever it is they're making for the customer. I always love looking at the tools, but they have a spring-loaded tool that holds it, that holds their screw gun in place. And those are really handy to have, especially when you have high volume production. So what he's basically doing is screwing in this cable with a screw and manually assembling it on this metal piece here. You'll notice, again, they have their work order and traveler so they can keep track and document everything that they're doing. As we go through this room, now you see the actual people working and putting the components through the circuit board. It's called a through-hole component. So the circuit board component will actually go through the circuit board, and the leads or the ends will be coming out of the circuit board down here. So it looks like these guys have already done their job. They're just waiting for something to be set up down here. And so they're able to take a break and relax. You'll notice that they all have ESD or electrostatic discharge bracelets on, which are tied to a grounding cable going from station to station. It looks like setting these up in the jigs might be a slower process than it is to put all the components in, but they have a series of people here that are taking the circuit boards, carefully transporting them onto the jig itself, locking it in, and once it's locked in, then they're able to feed it through the machine. Now, I've seen these jigs have top pieces as well, but these ones simply just have a tool that fastens them down and holds them in place. But I've also seen jigs and fixtures hold the circuit boards in place, because what happens is it goes through this melted metal, it sucks it in through that melted metal, and sometimes that metal will actually lift up the circuit board. So they have to make sure that it's fastened to the carrier so that it doesn't lift up, and they're able to get a consistent flow on the bottom of that connector. And as we come through here, you'll be able to see the liquid metal actually moving in this vat. Circuit boards are coming out here down at the end, and this one is still in the jig itself, and they are manually inspecting them. And it looks like on the bottom they have a type of a glue or adhesive material that has been used to hold that in place. And it looks like this guy is inspecting different parts that didn't get soldered very well, and he's making sure to solder, and he's inspecting them one by one. Like I mentioned earlier, in the perfect world, the machines would do it correctly, but in the real world, it's humans that have to fix all the issues. Now, this line over here is for small orders. So they might be doing small hand assembly jobs over here, and I hear snipping and cutting noise. So they have a special tool that will cut the bottom of the leads that are sticking out. So you'll notice if you zoom in here closely, he has a tool, he's manually snipping every single one. I've seen a really cool tool where it just automatically just cuts it. I think it was a pneumatic tool. So this is for smaller orders. The individuals are putting the components in place, and then they're manually soldering the backside of those circuit boards. And this is mostly for small production. Earlier, I was asking questions about how do they program the different boards? How do they know if they're working? And then they finally said, well, we'll go upstairs and we'll show you how we do that. And so this is that area where they have different computers. If they have a large order for a customer, they will actually buy the very expensive machines that's required. So this was like a $20,000 machine, I think they were telling me, for the production. So if they have large orders from large customers or even large orders from small customers, they will invest in those machines just to make sure that they have it available. More soldering. They're still doing more through hole over here as well. And real humans are really soldering these components together. There's something really cool I found that I've never heard or seen before back in the corner. So I want to show you what this is. And customers can make special requests. So one customer has a special jig that they want to be especially put together in a certain way, and they're also able to follow those instructions. Let me explain to you before I get into this room what we're doing, because this room is really loud. So come closer. See these different chests? We'll peek inside and you're gonna see dry ice. So they have dry ice in this yellow chest here. And then he has a dry ice gun. It shoots dry ice and air over the circuit board and over the assembled circuit board components. And it actually cleans the flux off of the circuit boards. So let's go take a closer look. So these look really clean. It's hard to see. Maybe the backside? Okay. If you compare this circuit board, you can see it has flux, and you can see that residue left over on the board. And then you compare this one, the residue has been cleaned away. And it looks like this tool was a very custom built tool, but I can't really tell. 你想 How cool is that? I've never seen that before. All right, finally, we're gonna go over here. And this is the final area where they do final assembly, final inspection of the circuit boards, and then they package them up. As you see, they've soldered cables into the circuit boards for this customer, and they're packaged and ready to be shipped. Maybe if you're from a big company, you've seen organization and technology like you're going to see here, but I have never seen some of these items. So I'm super excited to share this with you. Yeah, of course. So we have bins, we have parts receiving coming in here. And for that, they have stickers that go with every single one. Now, I asked earlier if it's one bin per customer, and they said, no, it just happens to be this way for this part. You know, maybe they're processing 1,000 of these pieces. They have resistors for 10 different customers. So it's not based on customer, but it's based on orders. I asked, what is the red bin? The red bin is for rush customers. So these ones up here, over here, those are all on rush. Black bins are just normal. And this is where they're kitting all the components, getting it ready for the circuit board assembly. Now, some of the technology I found really fascinating is just around the corner. I asked, what is the blue bin? And he said, the blue bin are for temporary. So check this out. She has a tablet and she has an ERP system that she's using to scan the components, and it's live. So they're able to track all the information for all the incoming components through their ERP system, and they know live what everything is and how everything's being. Another thing I found really fascinating was this. This is the machine I've never seen before. So he can take different components. He can take different reels of components, push it through this machine, and this machine will process it, and this machine will actually count the components. My mind was blown. Never seen anything like this X-ray machine before. There you go. 4,000, 5,000, 3,000, and 5,000. It went through this whole entire reel, all 4 reels, and processed it just like that. That's pretty cool, pretty fascinating. Now, in this area, they have what's called IQC. So IQC basically means that they're taking the different individual components. Before they go to the circuit board assembly area, they're testing all of the components, making sure that the component level is good. So they're testing every single component one by one, and they're opening it, putting them out, and one by one, they're opening every single bag of components and checking them, making sure that they look like they should, making sure the I guess not quantity, they're not counting it, but they're making sure that each component is the level that it should be. So they're verifying against what it should be here. They pull one component out of the tape. They're measuring the tape. That is a quick quantity check to identify the number of units on that reel or cut tape. They're taking the tweezers and pulling the component out. And they're measuring one of those components. They're changing the setting on the device to make sure that it is able to measure the component itself. And those components are so hard to see, it's like a grain of sand. And you see that one is an LED. So that little machine gives it light, and you can see that light was able to work, and they're able to see that it was green. She tried to pick it up. It's so small that piece just jumped, but she was able to recover it. That's how difficult it is. Then she places it on the circuit board and verifies on the computer that that is the correct positioning for that component. You'll notice on the back side of that yellow tool, it has a green and white sticker. That green and white sticker means that tool was calibrated. They had a company come in and calibrate to make sure that that tool is functioning the way that it should be. She's going to go over here, print a label. Everything was proved for that one component, and it goes into this bin, and she'll start on the next component. I've seen other companies do this, but at this level, this is pretty magnificent with the X-ray counting, the organization. They definitely have their SOP in place.